Okay, so we've just proven that if m is less than n, it's not an isomorphism because not one-to-one. Okay? And maybe I'll just remind us because not one-to-one. Okay? Now, if m is greater than n, I'm saying we don't have an isomorphism either, and if we can prove this, then we've proven that both spaces have to have the same dimension. Okay? Then if we know how the basis vectors here are expressed, the transform basis vector is expressed over here in terms of these basis vectors, we can do our matrix, okay? Or vice versa, okay? So I just asked, well, we've either got to prove that it's not one-to-one or it's not onto. And then I asked, which one do you think would be easier to prove? Okay, well, one of them would be very hard to prove that it's not because it could be, okay? But the other is obviously not, and you gave me a very good answer. You said, well, okay, now that space is bigger than this one, okay? So you transform all these vectors, you can't get all of these. There are things left over here. And you know that from the 4 basic subspaces and the stuff we've been doing, which is why I kind of like talking about isomorphisms late rather than before you use those 4 basic subspaces. Even though we kind of glossed a few things over in the process, it makes more sense now than it would have 3 weeks ago. Okay, so we talked about isomorphism just briefly, said what they were, and now we're trying to nail down the idea because it's a very central idea. So, okay, so we're trying to do that. So, intuitively, W is now too big. To hold all the images of vectors in V, right? Dimension is too high. Okay, well, a little more formally, what do you think we'd want to state? That's an intuitive statement. It's correct. It's great intuition. And our intuition leads us to rigorous statements that test and justify our intuition. Okay? Unlike the way people think about politics. Okay? Nothing rigorous there, just whatever you want to believe. And that's true not just for politics. A lot of that in politics right now. But you don't have good rigorous tests in politics, so it's true here. Okay, so anyhow, got this, right?
Mm-hmm.
So how are you going to make a rigorous statement that allows you to show why it's too big, other than your intuition that it is?
You mean to show that W is too big or that V is too small?
Well, they say the same thing, W too big, V too small. But what can you do? I mean, start with the basis vectors.
Because you have to have the same number of vectors for it to be a basis. And if you have less vectors, it can't be.
Yeah, and you mentioned that, okay? So I'm going to just take what you said and state it a little more.
Okay.
So, we'd like V1 through Vn be a basis of V. And what you wanted to say is, And what you really want to get at is that T of V1 through T of N can't be a basis of W. Why not?
Doesn't have enough vectors.
Huh?
Because it doesn't have enough vectors.
It doesn't,
Doesn't have enough vectors.
I didn't hear the word enough.
Okay.
I thought it was there, but, you know, okay? Doesn't have enough vectors.
Mhm.
Since God ain't enough vectors. I hate to lapse into formal mathematical terminology like this, but something like that. Okay? Well, how do we know it doesn't have enough vectors?
We haven't stated the basis for W.
We don't have to state a basis for W. There's just one property of any basis for W that would violate, which is same property we used over here.
Well, there has to be at least
M
M number of vectors.
Not at
in the
least,
base.
any basis has M vectors.
Right.
I mean, that was a good statement, but you want to be really precise and really understand that every basis has the same number of vectors and use that, okay?
Okay.
Now I'm getting a little, running the sentence on a little bit so you can be more grammatical. It's not ungrammatical, but it's, you know, kind of bad practice. You can refine things, okay? I don't want to give you a letter perfect proof. I want you to write your own, okay? To sort this out, okay? Okay, since, why?
Since any basis for W must have M vectors.
Okay? And I'll say, since every basis has M, which is greater than N vectors, this only has M, and this has M, right?
Mm-hmm.
Okay? Okay, so how does that violate one-to-one or onto? Which one does it violate and how?
Onto.
It violates onto what? Give me a good rigorous statement if possible.
Because
The dimension is not equal.
Well, we already
the projection.
established that, but what do we have to establish to prove that it's not onto? Well, let's review what onto means. What's onto mean? Because, you know, I mean, I remember struggling with one-to-one and onto for a little while. What's that mean? What's that mean? I had to keep reminding myself until it became natural, okay?
Fills the space.
The what?
It fills the vector space of W.
Talking about filling a vector space? Is that what you said?
Spans the whole vector
Spans.
space.
Spans.
Span,
space.
span.
Okay. Span.
What do you mean by, what spans what?
V would have to span, or the projection of V onto W must span all of W.
How does that establish onto? What's the definition of onto? You're right. I mean, everything you're saying is good. So I'm not saying you're not doing wonderful. You are. But we want to refine wonderful into perfect, okay?
Okay.
You guys are capable of it. So what? What's onto mean? What's the definition of onto? Doesn't say anything about projections. It doesn't say nothing about nothing, just except something very simple.
Basis of V.
No, it doesn't say anything about basis. We're going to be able to translate it into a statement regarding these, you know, this fact that this thing isn't a basis, okay? That's not what onto is. Did I ever say what onto is? Probably didn't write it down, okay? I said it, so certainly you ought to remember it. Well, if I don't write it down, I don't expect
Through
miracles.
linearity.
Do what?
Through linearity.
Has nothing to do with linearity. This stuff has to do with linearity, but that doesn't. Onto has nothing to do with linearity, although, and you can have onto maps of nonlinear spaces. any abstract space. Onto has a very general definition. Okay, well, I'm going to tell you. You have the intuitive idea. It just means well, that's a little bit intuitive. Comes from what's happening, right?
Yeah.
Now we're getting a little closer, though, right? And I'm going to cross that out politely, but it's still a good statement, okay? And I'm going to say, what's on to what, okay? T from V to W for any set V and any set W and any rule that maps all or some of V or all of V onto somewhere in W, okay? Every W in W equal to T of V for some V in V. And that leaves no wiggle room for faulty intuition. Doesn't mean you can't have faulty intuition about what it means, but if you really follow this, that's your guideline, that's your rigorous statement. Does that make sense?
Yes.
Okay, so onto means every W in W is equal to T of V for some vector V in V. And there are other ways to state it. I could say for any W in W, there exists a V in V such that T of V equals W. Okay? Yeah, this is upside down. It means for all. For any W in W, this means there exists a V in V. This means such that T of V equals W. And, you know, if you're really, you know, trying to write it out elegantly and compactly, that's the way you might write it. Don't expect you to use that, but I don't know. I learned these notations when I was 16 years old. So did everybody else in my senior class. Okay? And I think I started my senior year at 16, but within about 6 weeks I turned 17. I think I was still 16 when I learned it, which means we learned it early on, and I don't remember exactly. But it made perfect sense. I started writing, you know, you can easily start writing in that notation. You just, and it's much easier than sorting out what one-to-one and onto mean. Learning to use this notation, so I kind of recommend it. Okay. You don't see a lot of it in your book, so I'm not using it that much, but I thought I'd mention it here at the end of the course. Okay, good something to know, and something that really, everybody seen it before?
Yeah.
Yeah, you should have.
See bits and pieces everywhere.
Right.
Yeah, well, yeah, I mean, you know enough bits and pieces to understand that statement, so that's good. Okay. Yeah, I find that people aren't totally unfamiliar with it, but they're not totally fluent with it either. I mean, you get the logic notation and heavy mathematical logic. I try to remain as unfluent as possible. Because only insane people really get into that deep mathematical logic. Okay? There's a certain type of mathematicians that does it, and the rest of the mathematicians that does it, that do it, that respond to it. And no other mathematician even wants to look at it. It's very interesting, that dichotomy. Okay. And it's not quite that extreme. It's not a direct sum type thing, but you get the idea.